3. All right, let's do this. So yesterday we had the best time. I don't know if you remember yesterday, but I remember how much fun we had yesterday. And did you say I'm going to look it up?
Yes. There has to be like a trick to it.
All right, let's do. So we're going to do this one, number 4 here. Okay, we're going to do this one, number 4. I love this one. So let's go ahead and, so what I want you guys to do, okay, there has to be a trick to it, is that good?
Yeah.
Okay, so when we do these, what I want you guys to do is I want you to, on your pages, draw this. There are 3 locations, so you're going to draw 3 pies. Okay, you're going to draw 3 pies, and then we're going to fill them in. Is that cool? All right, so this situation looks like this, where when we start looking at it, the block is moving fast, then moving slow, and then not moving at all. Is that cool? All right, so when I go to draw my pies, okay, when I go to draw my pies, what should be true about the size of each pie? Okay, what should be true about the size of each pie? Oh, I should have graded those earlier. Where'd it go? No, we're just drawing. Okay. Okay, it's the top one. All right. So what should be true about the size of all 3 pies? They should be the same size, and that is because the total amount of energy has to stay the same. So pi. Oh, well, that was great, Don. That was excellent. All right, so yesterday we was using purple for elastic energy. That's just what I was using. So, and I'm going to do a diagonal down and to the right. And then for kinetic energy, I like to use blue. And we'll do, let's do horizontal for kinetic energy. E kinetic. And then for the thermal energy, okay, let's do the other diagonal. This is thermal energy. ETH for thermal. That's the energy you get when when 2 objects are rubbing against each other. Is that cool? And then what was our 4th gravitational, or what was our 4th energy? Okay, that was the gravitational energy. All right, and so for gravitational energy, we'll do vertical. That way, if you don't have colors, you can still do the shading in a way that's needed. Is that cool? All right, feel good about that? Man, me too. I feel tremendously good about this. All right, so take a moment, draw the pies, shade them in. Let's go from there. All right, I want to see you try. See what you get, and then I will show you what I got, and you can compare. All right? Don't just wait for me. I want to see you attempt to do it. All right? You have to compare your ideas to my ideas if it's going to make any sense. Okay? Okay. And 4 hearts. That was stellar. I can't believe I'm going to do it twice in a row. Draw some pies, please. Shade those pies in. Wheel banding all. We have abandoned all colors. We're just going with letters now. No, it's fine.
I have my colors down, so wait till I know it's right.
I love your colors. Man, I gotta tell you, trying to live Zoom is stressing me out. I'm glad I've abandoned that. I just couldn't do it. I couldn't. It's too hard.
So then you like mark people absent?
No, so you check in still. So you check in with me at the beginning of the class period, and then you can watch the video from the previous day, or use your time the way you see fit. But I still want you to watch the video at some point.
Yeah, I got the email like later on in the day.
Yeah.
And I was like, oh, maybe they're working.
So I did classes, just didn't Zoom it. Does that make sense? So, and you'll have time to catch up. All right, you guys ready? All right, tell me about the first one. What do you think about the first one? Mr. Peabody, what do you think about the first one? What kind of energy is manifest in the first one?
I think it's thermal and kinetic. I don't know about elastic.
So, are there any springs or rubber bands?
No.
No, so no elastic. Okay? Is it moving?
Yeah.
So totally some kinetic, right? All right? And you suggested there might be some thermal energy because we know it's rubbing on a surface. That seems really reasonable to me. Okay? What fraction did you want to go with?
I wasn't really sure, but probably maybe half and half.
Half and half? That's fine with me. Okay? Because we don't know, right? So he suggested half and half. That sounds good to me. Let's do half and half. He says, look, this thing is rolling, right? So we got half of it is kinetic energy. And the other half is the thermal energy that's generated by the rubbing between the block and the surface, right? Now, all right, let's do the next one, okay? Let's do the next one. Oh, and what do you think about the next one? How does this one compare to this one?
I said 2/3 thermal and 1/3 kinetic.
Here's the thing I like about that, okay? It's like you guys teamed up to come up with a good answer. Is the second one faster or slower than the first one? Slower, because it's slowing down, right? So you notice that there's less kinetic energy because it's slower. Does that gel with our concept of like our energy concept? Faster you are, the more energy you have? Totally works for me. I love it. What about the last one? Yeah, jump in.
Thermal energy, because it's not moving anymore.
Yeah, with Michaela on this one, I mean, if you think about it, it's not moving, so there's no kinetic energy. Energy had to go somewhere. It was all that thermal energy was generated that got released to the surroundings. I think that's awesome. This is a perfectly valid answer. I think it's great. This would show a 3 on an assessment, perfect understanding. Now, here's the cool part about this. You could have put this as all kinetic energy. It would have been correct. You could put it as 3/4 kinetic and 1/4. That's totally fine because we don't really know. So we start looking at it here. We know it's moving. It's moving slower, so you should have less kinetic energy, more thermal, and this one is all thermal. That's fantastic. Oh, is that it? You wish. All right, let's do another one. Ooh, let's do this one at the bottom here. I like this one. All right, so we got a block. It's pushing down on a spring of some sort. And that spring is going to launch it. So here, the block is at rest, so someone just let it go. Here, it's moving upward. Here, it's at its highest point, so it's stopped. Is that cool? So we got 3 pi's here. Oh man, my pi game is on point today. Look at how amazing those are. Not only are they good looking circles, but they're very close to the same size. Super proud of myself today. Hey, have you been to that Chipotle down on Mac? Is it good?
Yeah, but it takes a long time.
You don't like Chipotle? You say it takes too long?
It's good, but it just takes, sometimes if you come at the wrong times, it takes like an hour. But,
Oh, because it's just so busy right now.
yeah, it depends on hours. And also I don't think they're open later because of COVID.
Interesting.
Is it better than like other ones, or is it like?
I mean, I've had good experiences, so,
That's good.
except for the one.
I think Mrs. Pata has taken the boys there. I have not been there yet. I have not been there yet. That's right by the dome that they do the, by Kids Do Ninja Warrior. Yes? G, good. So that's the gravitational energy. That's the energy you get from when things go up in the air. So in middle school, you would have learned it as potential energy, but we're going to call it gravitational energy because it has to do with gravity and stuff. That's a great question. Thank you for asking. I forgot not everybody played yesterday. All right. Now, there are multiple right answers for this one. There are multiple right answers for this one. Okay? We'll start with Peter. Peter, what do you think about this first one here? Here's our object. What's the energy situation?
It's not moving, so I don't think it'd be kinetic energy.
I agree with that statement. He says, it's not moving, therefore no kinetic energy. Good, what else?
So it would be like thermal.
So-
activity.
It hasn't rubbed on anything, right? There's no rubbing between any surfaces, okay? So no thermal in this one.
Would it be like no elastic?
So it's pushing on the spring, right? Someone pushes against the spring and they're going to let it go. So by compressing this spring, we've absolutely stored some elastic energy in this. Is that cool? Now we're going to go all elastic to begin with, and then we're going to see a different answer here at the end.
Okay, I have a question.
Sure.
Would it also be halfway like gravitational?
So
It's getting pulled, or is that wrong?
So right now, it all depends on where you want your zero height to be. So right now, the ground is all the way down here, true? If I make the ground, my height equals 0, then is this block above the height equals 0? So if we do that, then we're going to have to include some gravitational energy in here.
Okay, gotcha.
Okay? But it's not the fact it's being pulled, it's whether it's up above a height or not.
Okay.
Okay? So if we do that, then we'll say this is the starting height here, so it's up here, so we're going to have to include some. Now, if you said that the lowest height of the box was the 0 height, then we would have been right in our original answer. But this is good too. This totally works for me. All right. What about this one here? It's on its way upward, and it's much higher than the previous one, right? Jason, tell me what you think about this one.
It's probably half thermal, not gravitational.
Say it again louder, please.
Is it half thermal, not gravitational?
There's no rubbing. There's no surfaces rubbing against each other. So we're not generating any thermal energy in this one. Okay? So it is up, so there's definitely gravitational energy. But what's the other question? Is it moving? Go ahead, Eli.
Half gravity, half kinetic.
Yeah, he says half kinetic, half gravitational. I'll totally buy that. And what about the last one? Oh, sorry. Ooh. the very last one. Yeah?
It's all gravitational.
All. Do you see me just push this math above my eyeballs? That's why you can't see when it's over your eyeballs. I agree. I think it's all gravitational because of the fact that it's not moving, it's not pushing or pulling on any springs, and there's no thermal energy generated because it's not rubbing on any surfaces.
So the first one has some gravity.
So it doesn't have to, it just depends on where you want to designate your lowest point at. So there's two right answers for this one. You could do it with the gravitational or without, and they would both be right. Okay? So let's talk about these things. All right. How do we know if we have kinetic energy? Yes?
If it's moving.
Absolutely. Okay? How do we know if there's some elastic energy? Springs and rubber bands, yeah. Okay? How do we know if there's some gravitational energy? It's got to be up some height. And what about the thermal energy? How do we know if there's thermal energy?
Rubbing or something.
Yeah, if there's rubbing with friction. All right, how's that? Is that cool? So the goal is to practice enough so that you guys feel good about, oh, I like this next one. I like this next one. All right, so we have a piece of clay and it's dropped to the floor. So, was that me? No, that wasn't me. That was you? So you have a piece of clay, it's here, it's here, it's here, and then it hits the floor and splats and stops. Is that cool? All right, so let's draw this bad boy up and see what we can get. Okay, we got 4 instances. We're going to need 4 pies. Oh my gosh, it's like I'm like a robot today. Look at those. So a piece of clay is dropped, so we're going to assume it's dropped from rest. Okay? We're going to assume it's dropped from rest. You're looking at me shockingly attentive there. I was like, Larry, you're left-handed? How long have we known each other? I didn't know that. Wait, why do I feel like we've had this conversation? This is Pat, huh?
What's up?
What's happening? Look at these great kids.
I know, this is like a packed class. No, really, like
I know.
in comparison.
You guys know Mrs. Pata? This is my lovely wife. What
I
do you
taught with
do?
Mr. Burns' class.
What do you do?
Oh, hey, we need to talk, right? Did you get some stuff in?
Yes, I did.
Perfect, okay, I gotta look through.
Mhm.
I will.
Uh,
Thank you.
What's happening?
I was teaching with Mr. Burns' class, it was better for me to just come in. Michael's hopefully not trying to cook or something. So
Awesome.
headed back home for quarantine teaching.
Okay, I'm gonna do after school.
You need to hustle. Get it home.
No, after I'm done. Got it.
Yeah.
All right, so let me know if you need anything, okay? Isn't she the best, Mrs. Bannon? Oh my gosh, she's so awesome. So Marshall, she's talking to me because Marshall, my big boy, got quarantined from, he goes to school at Pierce Middle School, and he got quarantined. So he's home, and ostensibly she's home with him, but she's doing her librarian job, teaching some classes, and so she had to come in to teach with Mr. Burns. So he's home by himself. He's 10, he's almost 11, he's fine, but I don't think he's that bright. So we'll just see. We're hoping for the best. I don't know. We'll just, I mean, I'm not, I mean, he's great, but I don't know. All right, here we go. Tell me about the top one. Oh, wait, tell me about the top one.
I said it's all gravitational.
I did also. So it's not moving. There's no friction rubbing. There's no springs or rubber bands. It's up a height. I agree. All right, now what about the second one here? Michaela, this is your big moment. What about the second one here?
Gravitational and kinetic.
I agree 100%. He says, look, it's moving now, so there's got to be some kinetic. It's lower, so there's less gravitational. Okay? What about the next one? Yeah.
Also going to be gravitational and kinetic, but there's going to be more kinetic energy than gravitational.
Yeah, so this is cool, right? So she's like, look, we're still going to have the same, but this time, now what about a last one? What's that? Ooh, Jason, what do you think?
It was just all thermal.
All thermal? What did you think?